We're now going to discuss light refraction. The speed of light changes in different mediums of different densities. When light travels from one medium to another, its speed changes and the light is bent. This bending is called the refraction of light. In light refraction, the light is not reflected. Water is one medium that we'll look at. When light travels in the air, it goes in a straight line, but when light travels in water, it slows down and changes its direction. We'll use water as a medium to look at measuring the angle of incidence. The angle that the light enters the surface is the angle of incidence. You'll notice in the diagram to the right that the light's hitting the water. The angle that the light hits the water is the angle of incidence. So how do we measure the angle of incidence? Well, the angle of incidence is measured from an imaginary line that runs perpendicular to the boundary between the two mediums, in this case air and water. This imaginary line is called normal. The angle of refraction is the angle at which the light changes its direction in the medium, in this case water. This is measured from normal to the refracting ray. Unlike reflection, the angle of incidence and the angle of refraction are not the same in light refraction. Each medium that light travels through has its own refractive index. The refractive index is the speed of light in a vacuum divided by the speed of light in a medium. So what is a vacuum? Well, a vacuum is a simulator that simulates empty physical space. You can see from the two pictures on the right that vacuums can be very simple or very complex. Some common refractive indexes would include the index of a vacuum, air, water, and ice. Next, we're going to look at total internal reflection. Total internal reflection is when the angle of incidence increases beyond the critical angle. This will cause the entire light to become reflected back into the same medium. At a certain angle of incidence, the angle of refraction is 90 degrees. This angle of incidence is called the critical angle. When light travels from a rarer medium to a denser medium, it bends towards the normal, but when light travels from a denser medium to a rarer, it travels away from the normal. This bending of light has many implications, one of which is a mirage. Mirages occur in very hot conditions when a layer of hot air is trapped between the ground and the cooler air above. Since there are different layers having different densities, the light travels in different densities. Finally, the light is made to travel upward with total internal reflection. This gives the impression that the light is coming from the object underneath. This makes it look as if there's a pool of water at some distance.